then even RMS velocity might not be correct. Just use p squared. You have to have more powers. You see that? You can retain the next term. That means you have more powers in the equation. X squared, x power of 3. Otherwise, you can use the normal move-up correction, which gives you a normal move-up velocity. It's somewhere. Somewhere. Talk about normal move-up velocity. Yeah, but it's here. We look at the normal move-up velocity. I think I missed the normal move-up velocity somewhere. Oh, yeah, I see the so it gives you you have to use the normal move-up velocity. I still have good eye, but sometimes I miss about it. Sometimes you miss about it. So Vn is a velocity required to best NMO correct. We'll see how to do this, and you will have to do some exercise. So, is the velocity required to best NMO correct the data using hyperbolic NMO assumption? The difference between NMO and stack velocity is very small. So what is stack velocity? I'll introduce you another velocity, stack velocity. But they say NMO velocity and stack velocity are different. And then in the first paragraph, we say where you can use this RMS velocity and where you can use the normal velocity. So when you do processing, you just don't use one velocity. You have to use different type of velocity, and depending on the constraint that you see that here it have been mentioned that. But how do you put the constraint? It's only your mind that you can use. You have to probably assume a lot of things or take account of other things. Okay, this stack velocity. This is the velocity required to best stack the data using best fit hyperbola over available offset range. Yeah? The choice of stack velocity can be rather subjective. Most of them are subjective. Because we are not into this. A lot of the thing we assume a horizontal layer. That is our problem. However, it turns out that an appropriate choice can cover for a multitude of assumptions. What are the assumptions? There are quite a lot. It will be based on mathematical assumption, based on structural assumption. So there are a few assumptions that can be made. But we are not talking about this because not really. We are looking only at the idea of the processing assumption. This one all will be put inside the mathematical program. Okay. For horizontal layer, small offset, this stack should be equal to RMS. And just now we use the RMS, so this is stacking. But for high, because we have to include the angle. One include the angle, one include the more inhomogeneity that you have when you have a more space in the distance between source and the geophysic are very far apart. You might have more inhomogeneity, so you have to include that. That is the limitation. So this assume not 3D effect. The application of big move out from this is to remove the big effect from this stack, so that this stack approximately RMS. So you also have to include actually this now then come again you have dB average. When do you use the dB average? Yeah. The average is often used for depth conversion. So in the processing you don't use the average. The average you use only when you do the from time to depth from the time to space moving. Okay. But it's only valid where the velocity varies only vertically. Okay. Varies vertically. But varies horizontally, like you have a fault, then you have to do something else. Not something else, you have to add more processing of the relation. Okay. Then you have another one which is called demigration. MIG is for migration, AB for area. This is the velocity required to best migrate seismic data and is related to the true interval velocity, not the static velocity. So the migration is more related to the interval velocity. So that's why you need to understand each of those terms and when to apply it, and when to apply it. Okay? So let's have a look a little bit on the normal movement. When do we need? This is normal, the normal movement velocity estimation. Okay? When do you need the NMO? When do you need the RMS velocity? Normal movement velocity and this velocity and this NMO velocity and the RMS velocity. You know how to get the RMS velocity, yeah? Now let's try to see if we can see how we can get the I make a copy somewhere. Does it come out? Yeah, I have it somewhere. I have it somewhere. Why? Why apa yang saya nak tunjuk tadi ya? Exercise. NMO exercise. Sama pula. Or maybe satu tak dibuka. Di sini lah, di sini tu boleh buka dan ada dah show in the folder beberapa kali. This is the one. Okay, effectively, I just want to show you this first before I explain. Okay? What we have, kalau I will show you some of the diagrams. I think I have another diagram there, which will show you what is actually how NMO works. Okay, this basically explain NMO. This figure, bawah dia give you all the rubbish that you need to remember. But this basically explain. Remember the first thing that you need to do when you acquire data, and when you acquire data is to get the CMP ni kan. Whatever you do, you have something like this or something like this. And then we have the source there. If we have the source there, then we should be something. We should be getting another one, something like that. So that is the CMP. I think I have a video also, that video issue. So what you do is you try to collect, one is the source from here, and so you have to collect this, and probably if another more, you have to collect that also. So eventually you can get that thing. That is the first thing that you need to do, is to do the CMP gather and process. Once you have got the CMP gather, but each of the gather, this one, each of the traces look something like this. Yeah. This one show just 3, so you have each of the traces. Each of the traces will show you something like this. But what we need is to end the purpose of the purpose of stacking and doing this normal mobile is so that it will be aligned, so that this one will, because this one come from the same point, yeah, we need to align it so that we can get a two-way time. So this one is supposed to be coming from the two-way time. So if you plot, everything gets from two-way, so the two-way time will be from there. So you have to shift it up there, so that you can align it something like this. Yeah? So basically, it should be 1, 1 also should be coming from 0, 0, 2 kalau if this is 0, 0, center is 0, 0. 1, 1 should be corrected so that it be just showing the 0, 0. Mean you have to remove part of it. You remove part of the time so that 2 become also two-way time. 3 also become two-way time. So the way that it remove is, if you look at the diagram, if you look at the traces, plot of the traces, it is plotting, of course plotting, this one has a shorter time, this one longer time, this is the longest, shorter, longer and longer. So it is something like that. But essentially we want to correct it for TO. Where is the TO? Two-way time is somewhere there, correct? Right? Yeah? So it should be shorter than 1, 1. Should be shorter than 1, 1. So it is somewhere there. Yeah? So what you want to do is to shift, to remove the bit that is between there and there. Yeah? If you draw a line, so if you draw a line something like this, that is TO, two-way time there. Yeah? And x is equal to 0. So what you want to do is actually shift everything. Not shift, actually remove that, probably the word is remove. Remove that part. This one called delta T. You'll see in the equation that is a delta T there. You have to remove that. Once you remove, then you can get this thing. Then you can do the stacking. That is what you do. You remove and then you stack it up. So that you can get a better signal. That is the idea of doing normal mobile. If you look at that, the example, okay. This is just one of these, yeah. Look at one of these, yeah. Look at one of these. See, look at that. So what we need to do is, instead of having that curve, we want it to be along a horizontal line. Either here, if the two-way time is here, then you have to remove and move it up here. Yeah. If it is here, then here. So assuming it is here, then you can try to shift this one by removing the time between that point and that point. So the time you can calculate, you calculate using various velocities. You put, that is the equation, yeah. That delta T and MO is actually the difference with that point and that point, that point and that point. For on any distance x, this one is 800, this one is 800 x. TO somewhere up there. You can just assume a TO at that one. Yeah. You can also assume a different one. So if you use different velocity, put the velocity there. Say if I put a velocity of 2000,